In our first unit of physics, we're going to be learning about objects that are moving at a constant velocity, and we'll understand exactly what constant velocity means in just a few moments. We're also going to be treating our objects as particles, meaning that they don't really have a size. Therefore, this first unit is called the constant velocity particle model. In this unit, we're going to be learning two different learning objectives: being able to draw diagrams to model an object that's moving at a constant velocity, and being able to use diagrams and calculations to write arguments about objects moving at a constant velocity. In order to understand these and in order to analyze things moving at a constant velocity, we need to know some terms. So this video's purpose is to introduce you to some of those terms. We'll start out with two terms that we'll use throughout the year called scalar and vector. A quantity is a scalar if it's a measurable quantity, versus a quantity is a vector if it's that measurable quantity but also has a direction. So the big important distinction between scalar and vector is that vector has a direction. I gave you some examples for symbols that may be used for quantities that are scalars versus quantities that are vectors. And you'll notice the biggest difference between the two is that symbol on top of the letter. We call that the vector symbol. An example would be Ellen drove 5 kilometers. That 5 kilometers is a measurable quantity, and so that would be a scalar. But if we add the word west onto that 5 kilometers, my measurable quantity now has a direction, and so that would be a vector. For the remainder of this video, we're going to learn about several quantities that will fall into the scalar or vector category. Starting out with an object's position. The position is defined as being the location of an object from a reference point. That reference point, otherwise known as the origin, is where we consider the position to be 0. Sometimes the origin or reference point might be where an object starts moving, or sometimes it'll be otherwise defined for us. The symbol for position is a letter X. It has a unit, the standard unit at least, being meters. And an example would be that the object is 0.5 meters to the right of the door. Now it's really important here that we not just say that it's 0.5 meters, but it's 0.5 meters from what and in what direction. So here we know that it's saying from the door, and so the door is likely our origin, and it says that it's to the right of the door. Again, knowing exactly where, because 0.5 meters away from the door could be anywhere in a 360-degree circle. Another quantity that we're going to use quite a bit is a quantity called displacement. And displacement is the change in position of an object. So we're looking at an object that has moved, and we're looking at the difference between its final position and its initial position. When you notice that symbol, you'll see that it's a delta X. Anytime we have a change in something, we use that delta symbol, and it has a vector symbol on top of it. So knowing that we have to pay attention to direction with displacement. The unit of displacement is meters, once again. And an example is that Diego walked 3 meters to the right, then turned around and walked 5 meters to the left. His displacement would be 2 meters left of his starting position. Displacement is different from distance. If we had been talking about distance, we would say that Diego had traveled 8 meters, because that's how far he walked. But displacement is that difference between where he started and where he finished. Next, we'll talk about average speed. Average speed is defined as the distance an object travels divided by the travel time. So notice there's that word distance in here. The symbol that we use for speed is a letter S, and you'll notice that there's no vector symbol here, so this is a scalar. The standard unit for speed is meters per second. And an example would be that Sam drives 150 meters in 10 seconds. So her average speed is 15 meters per second. Taking that distance, 150 meters divided by that travel time, 10 seconds. A quantity that's similar to average speed but slightly different is average velocity. Where average speed is the distance divided by the time, average velocity is the displacement divided by the total time. My symbol, which is a letter V, now contains a vector symbol, indicating we have to pay attention to direction. We still have that standard unit of meters per second. In looking at our example, it looks quite a bit different. We're going back to that idea that Diego walked 3 meters to the right in 6 seconds. He paused for 4 seconds and then turned around and moved 5 meters to the left in 10 seconds. His average velocity, it says, is 0.1 meters per second to the left. So thinking about how we got there, we took the displacement. Now, we know from the slide on displacement that Diego's displacement was 2 meters to the left. And then we divide that by the total time that it took. So the total time being 6 seconds plus 4 seconds plus 10 seconds. So we have 2 meters to the left divided by 20 seconds. And that's how we come up with this average velocity of 0.1 meters per second to the left. So a big thing I want to point out is when we see that word average here, we're not talking about averaging two different velocities. Instead, average velocity has that meaning of taking the total displacement divided by the total time.